Hello my dear children, welcome to my channel Sudhir Chemistry. But today we are going to discuss another topic, that is aryl halide. It is also called as haloarenes. It is also called as haloarenes. But a haloarenes means it is a phenyl ring will be there called as a benzene ring, and this phenyl ring is bonded with a halogen called as a aryl halide. Here we are going to see about the example which one in aryl halide we are going to discuss. We are going to discuss about chlorobenzene. But a chlorobenzene means it is a benzene ring having a chlorine over it called as a chlorobenzene. And in this one we are going to see the method of preparation of the chlorobenzene. How the chlorobenzene can be prepared. The chlorobenzene can be prepared. One of the best method is there. It can be prepared directly from the benzene. Now we'll check it here. From the benzene how the chlorobenzene can be prepared. Right, beta? For example, beta, we have seen that in the aromatic hydrocarbon like in the benzene, it undergoes electrophilic substitution reaction. Example, chlorination of the benzene. Here, suppose it is a benzene ring, and if you do the chlorination over it, means addition of chlorine can be done in presence of a Lewis acid. Do you know what is a Lewis acid? We are using either anhydrous AlCl3 or FeCl3 or FeBr3. But it is going to produce the electrophile as a Cl plus, and this will attack over the benzene, and we are getting here as a chlorobenzene. Remaining byproduct is the HCl. So but it is a one of the method. It is a one of the method where we are able to convert the benzene into chlorobenzene. Second important method is that to prepare the aryl halide is by the diazonium compound. But before that, I want to go with one more example, that is a toluene beta. Suppose if we have the toluene, and if you do the chlorination over the toluene, and that to be in presence of iron but in absence of light. But I want to show you two reactions here. Actually, toluene में this benzene methyl group is electron donating group. It will increase the electron density at the ortho and at the para position. But a chlorine with iron, it forms the electrophile as a Cl, and these electrophile can attack at the either at the ortho or at the para position. So we are getting here as a methyl benzene attached with a Cl at the ortho position, or we can say beta it is a methyl benzene, it is attached with the Cl at the para position. But if the same reaction will take place in presence of sunlight, and you know beta due to sunlight it will favor a free radical mechanism, and due to the free radical mechanism it will form the radical at the methyl group. The most stable free radical will obtain at this point. This is the most stable free radical, and in this one beta Cl radical will attack over it, and it form here as a benzyl chloride. So this is the most important reaction, that chlorination on the toluene or methyl benzene. This is called as a toluene or the methyl benzene. But in absence of light, orthopara. In presence of light, favor free radical mechanism, and it form benzyl chloride. But in the same way, chlorobenzene we are able to prepare, bromobenzene we are able to prepare, but we are unable to prepare the iodobenzene, because during the formation of iodobenzene, the byproduct will get as a HI, and HI beta it acts as a strong reducing agent. It will reduces the iodobenzene back, means it will make the reaction to favor backward direction. To make the reaction in the forward direction during the preparation of iodobenzene, we have to use oxidizing agent like a HiO3 and all. By using this oxidizing agent, we can make the reaction to goes on forward direction. So it is a method easily we are able to prepare chlorobenzene and bromobenzene. Iodobenzene cannot be prepared because during the preparation of iodobenzene, it form HI which act as a reducing agent, and it will make the reaction to goes backward direction. Fluorobenzene is unable to prepare because the property of the fluorine is a explosive nature, and because of its explosive nature, high reactivity, we are unable to prepare the fluorobenzene. Right? Next one is, we'll go with another method, that is a preparation of this chlorobenzene. Commercial method is called as a Rastick process. But here only I'll write one of the method, that is a commercial method, And this commercial method is used to prepare chlorobenzene, and the name of that is a name reaction called as a Raschig process, RASCHIG. But with this process we are able to prepare the chlorobenzene, but it is a commercial method to prepare the chlorobenzene. For that one, benzene on oxidation in presence of acid. See beta, it is a 2 moles of benzene on oxidation in presence of acid. Acid is what beta? HCl is the acid, right? And this reaction take place in presence of a catalyst like a CuCl2, and on heating, beta, it form here as a benzene ring with Cl called as a chlorobenzene. But a remaining byproduct as a water molecule will come off. So it is a commercial method to convert benzene on oxidation in acidic medium gives rise to chlorobenzene. It is a commercial method. But a second one, preparation of this chlorobenzene can be done from the diazonium compound. Second method I will tell you, that can be done from diazonium compound. Diazonium compound. But a diazonium compound is nothing but a benzene diazonium salt, we can say here. For that one, what we required for diazonium compound, or for this diazonium compound के लिए what we required, but we required here as a, we'll take aniline. You know, benzene ring bearing NH2 group is called as a aniline. But aniline on treated with the nitrous acid. But a nitrous acid should be freshly prepared. If it is not available, we can prepare it. How? By reacting NaNO2 with HCl. You can see H from here, NO2 from here. They combine at 0 to 5 degrees centigrade, and it will convert this aniline into diazonium salt. Benzene ring bearing N2 plus Cl minus, and it is called as a benzene. N2 plus means diazonium, Cl minus means chloride, but it is a diazonium compound. Means what is this benzene ring bearing NH2 group? This is called as a aniline. On reacting with nitrous acid at 0 to 5 degrees centigrade, it gives benzene diazonium chloride. But these benzene diazonium chloride, now it will undergo the further reaction. I will show you two reactions are there. Suppose you are treating it with a Cu2Cl2, right beta, in presence of HCl, or suppose if you are treating it with a copper powder HCl on heating, but it will be converting diazonium salt into what? Chlorobenzene, and it will be also converting this diazonium salt into chlorobenzene. But you know, when you are heating this diazonium salt with Cu2Cl2 and HCl, this name reaction called as a what? Sandmeyer reactions. This name reaction is called as a what beta? Sandmeyer reaction. And when we are making this chlorobenzene by heating diazonium salt with a copper powder, then this is a name reaction, and beta, this name reaction is called as a Gattermann reaction. But one is a Sandmeyer reaction, other one is what? Gattermann reaction, where we are able to convert diazonium salt into chlorobenzene, diazonium salt into chlorobenzene. Is it clear, beta? Now, sir, how to prepare the bromobenzene, how to prepare the iodobenzene? I'll tell you, beta. If it reaches up to the diazonium salt, suppose if we are using Cu2Br2 in presence of HBr, we are able to prepare beta bromobenzene. In all the cases, beta, byproduct is what? N2 gas, right? Byproduct is what beta? N2 gas is the byproduct we are getting here. Plus of N2, here also plus of N2. But see beta, we are using Cu2Cl2 HCl, Sandmeyer, Cu2Br2 HBr, Sandmeyer. But wherever we are using copper powder HCl, it is called as a Gattermann. Sir, I want to prepare iodobenzene. But from these diazonium salt, we should not add the Cu2I2 and HI, because if we add the HI, but HI will act as a strong reducing agent, and it will make the reaction to goes backward direction, that is reversible. So to avoid it, this diazonium salt, it should be treated with the Ki. Means it should be warm with a Ki. It will be converting into what beta? Benzene ring bearing iodine called as a called as a iodobenzene. Called as a what beta? Iodobenzene. But now we will see the chemical properties of this aryl halide. And in these chemical properties, I am going to discuss with you nucleophilic substitution, but a nucleophilic substitution reaction. We'll discuss about the nucleophilic substitution reaction. I will tell you better here aryl halide and alkyl halide. Suppose this is a aryl halide and this is a alkyl halide. This one is what beta? Alkyl halide. And this one is what you know? This one is aryl halide. But in this case, my halogen is bonded to the carbon and this carbon is a sp2 hybridized. But alkyl halide में halogen bonded to the carbon and this carbon is a it is a sp3 hybridized. And as we know beta in sp2 hybridized carbon में percentage of s character is 33.33%. And in sp3 में percentage of s character is what beta 25%. Greater the percentage of s character, greater the electronegative atom is. Now if I will ask you which carbon is more electronegative, either the carbon of the aryl halide bonded to halogen or the carbon of the alkyl halide bonded to halogen. So what we will say, greater the percentage of s character, this carbon atom is more electronegative. But more the electronegative, smaller the bond length than the bond length between carbon halogen of alkyl halide. So smaller the bond length, greater the bond energy. And but greater the bond energy, right, less the reactivity. So I will say because of these reason, beta, our aryl halide are less reactive, beta are less reactive towards nucleophilic substitution reaction than alkyl halide. I repeat beta here. Aryl halide are less reactive towards NSR nucleophilic substitution reaction than alkyl halide. What is the reason? But a carbon of the aryl halide is a sp2 hybridized which has greater percentage of s character than the percentage of s character can be seen in the alkyl halide. Greater the percentage of s character, greater the electronegative atom, and greater the electronegative atom, smaller the bond length, greater the bond energy, less the reactivity. So what I will say beta, aryl halide are less reactive towards nucleophilic substitution reaction than alkyl halide due to the following reasons. Actually, this is the one of the reason I gave here. But again, I will say beta due to the following reason. Beta reason number 1. Partial double bond character. Partial double bond character in carbon halogen bond. Beta in carbon halogen bond in aryl halide. Partial double bond character in carbon halogen bond in aryl halide. This is the one reason. If you want to see beta partial double bond character, I will show you this one on here. See beta, it is a phenyl ring having a alternate pi bond bonded with the halogen chlorine, and chlorine is having 3-3 lone pair. So as it donates its electron, this pi bond shifted here, and due to that, this is a resonating structure we are getting pi bond, and this is a negative beta. I will get double bond and positive. See beta, in between this carbon and halogen chlorine, we are getting partial double bond character. But a remaining resonating structure also we can draw. Pi bond shifted here, it become negative. Positive negative will make double bond. then remaining this one Cl positive. But one more, this pi bond shifted back to this carbon. Actually, place is not there. I will draw on this side. Beta. It is a here positive negative pi bond. On this point, beta negative. Then double bond Cl positive charge and this pi bond. But now this pi bond shifted back to chlorine, and we are getting the resonating structure in this way. See here, one here, second here, positive negative will make double bond, single bond, then Cl, and we are getting its three lone pair. But a 1, 2, 3, 4, 5. How many? 5 resonating structure, and everywhere you can see beta carbon halogen, carbon halogen, carbon halogen will have a what? Partial double bond character. But a partial double bond character means due to the partial double bond character, the bond length between carbon and halogen decreases, bond energy increases, its reactivity also decreases. So what we can say, beta, aryl halides are less reactive toward nucleophilic substitution reaction than that of alkyl halide due to the given reason. Right? It is the first part. Second reason also we can say, beta. The second reason is that hybridization of carbon in carbon halogen bond. Second reason, hybridization. But hybridization of carbon in carbon halogen bond. I think you saw it. This reason it is there on the board. Carbon of aryl halide is in sp2 hybridized, but carbon of alkyl halide is in sp3 hybridized. But in sp2 hybridized, percentage of S character is 33%, but in sp3 hybridized, percentage of S character is 25%. Greater the percentage of S character, greater the electronegative atom. As this carbon is more electronegative than this carbon, so this carbon, it will pull the electron from the halogen and decreases the bond length. But as the bond length decreases, bond energy increases, reactivity decreases. We can say aryl halides are less reactive toward NSR than that of alkyl halide. Right, beta? Next one, third reason we'll write. One more reason, polarity of carbon halogen bond. Third point, beta, we can see reason. Polarity of carbon halogen bond. Now if I will ask you, beta, in this one which is having more polarity? But this carbon halogen bond of alkyl halide is having more polarity than the carbon halogen bond of a aryl halide. So greater the polarity, easily will break the bond. Easy will break the bond, more the reactive toward NSR than the reactivity of the carbon halogen of aryl halide. Is it clear, beta? Polarity of carbon halogen bond means what to say? Carbon halogen bond of alkyl halide will have a more polarity. Beta, more the polarity, that means what we can say, more the reactivity. So what we can say, alkyl halide is more reactive toward NSR than the aryl halide. These is the three reasons, beta, which one I have given. Some more reasons are there, but no use. Anyway, I'll tell you, beta. Instability of phenyl cation karke they will say. Instability of phenyl cation. But instability of phenyl cation means what? I'll explain you. Suppose I am having, this is a aryl halide. This is a aryl halide. To when the nucleophile want to attack over it, beta, here halogen should leave away. But as a halogen will leave away, it will form the positive charge over the benzene ring. And you know, forming a positive charge or radical on the benzene ring or negative charge on the benzene ring will make it unstable. So instability of phenyl cation. So this is also one of the reasons which says that, beta, aryl halide will be less reactive toward NSR than that of alkyl halide. Now we will see the complete NSR reaction of the aryl halide. But now in this nucleophilic substitution reaction, we have seen that the aryl halides are less reactive toward NSR than that of a alkyl halide. As it is a less reactive, so then also some methods are there, beta, where we are able to replace the Cl of the benzene ring with the nucleophile like a OH. That will be called as a replacement of OH group, or we can say, beta, replacement of the Cl group by the OH group. So better to say beta replacement by hydroxyl group. Replacement by by hydroxyl group. But a replacement by hydroxyl group में what the name of the process called as a Dawes process. But as we know कि halobenzene, that means a aryl halide, this is a chlorobenzene, it is a less reactive toward the nucleophile. So we are able to provide at high temperature and at the high pressure, we are able to make it to react. What is that beta? कि it is reacting with the nucleophile, that is a NaOH. Actually in that way OH minus is going to attack over it. For that one beta temperature is 300, sorry, pressure is 300 atmosphere and temperature is 300 degrees centigrade. In our NCRT they are writing beta 350 degrees centigrade and in some book they mention as a 300. So at high temperature and at the high pressure, right? What happened beta here? He Na and Cl will come off. So NaCl came off. Right beta, Na and Cl came off. At the same time, water molecule also came off beta here. That means OH and H from here it came off. And this part beta, ONA part is going to attack. So make it balanced by putting 2 moles of NaOH. Benzene ring was attacked by ONA group. Beta benzene ring with ONA called as a sodium pheno oxide. But these obtain sodium phenoxide, it is a salt. Now on acidification, means on acidification beta addition of water in presence of acid, it will be converting ONA into what beta benzene ring bearing OH group and this will be called as a phenol. So what is a Dawes process beta? The process where we are able to convert chlorobenzene into but we are able to convert this chlorobenzene into phenol. For that one it required very high temperature 350 and pressure also high pressure, that is 300 atmospheric pressure. But as we know the reactivity of aryl halide toward NSR is very less or low, but we can increase its reactivity beta. How? We can increase the reactivity of aryl halide. How? If we attached But if we attach, what is that? Electron withdrawing group. Do you know what is electron withdrawing group? NO2 group, CN group, CHO group, or ketone group, or acid group. If we attach electron withdrawing group at ortho and para position, then we can increase reactivity of aryl halide. But we can increase reactivity of what you know? We can increase reactivity of aryl halide towards NSR, towards nucleophilic substitution reaction. For example, I will show you. But it is a chlorobenzene and I am attaching the electron withdrawing group like a NO2 group. Beta. I am attaching the electron withdrawing group like a NO2 group. That to be at ortho and para. So better we will make it as a beta para position. It is a one case. Second case also I will show you. Suppose I am having a chlorobenzene and I want to attach beta two electron withdrawing group. One is ortho, one is para, right? And one more I want to show you beta. It is a aryl halide, that is a chlorobenzene, and it is attached with a 3 electron withdrawing group, that is a NO2. That to be both at the ortho and one at the para position. See beta, reactivity will increase. How the reactivity will increase? Just see the temperature here. When it is treated with the NaOH, but when it is treated with the NaOH, initially temperature is 350 and pressure is 300. Now temperature reduces to what beta? 160 degrees centigrade followed by hydrolysis. And here our Cl is there, it will be converted into OH and we got here as a NO2. Called as a what beta? Yes, it will be called as a para nitrophenol. Here 2 withdrawing group is here. So when you are going to react it with the NaOH, temperature instead of 160 beta it become a 95 degrees centigrade followed by hydrolysis in acidic medium, Cl converted into OH and remaining one NO2 is at the ortho, one more NO2 is at the para. See beta, 350, then 160, then 95. Here, no electron withdrawing group, temperature 350. One electron withdrawing group, 160. Two electron withdrawing group, 95. Now, see for this case. But no need to add any NaOH. Directly in this case, may add the warm water. Because see, 3 withdrawing group is here. Reactivity of this toward NSR is very high. Thus, you add the warm water. Beta. Warm water में water का OH will attack on the chlorine, and we are getting here as a phenol with a 3NO2 group. 2 is at the ortho, 1 is at the para, and it is called as a 2,4,6 trinitrophenol. Remember beta, 2,4,6 trinitrophenol is also called as a picric acid. Beta, it is an acid without COOH group. You can see this is acid we got without COOH group. Now beta, after this nucleophilic substitution reaction, that is replacement by hydroxyl group, the another one we'll see reaction. This is nucleophile substitution. The second one is reaction of this aryl halide with the metals. That means we can say beta here reaction with metals. Reaction with the metals. For example, if we have the aryl halide, beta this is a aryl halide, then 2 moles of sodium, and we'll take 1 mole of alkyl halide, Rx, right beta? I'll take here also X. Beta 1 mole of alkyl halide Rx. This X from here, Na from here, and this X from here will take out. What we got beta? Benzene ring bearing R group called as a alkyl benzene. 2NaX came off. Beta this is a name reaction, you know, and this name reaction called as a Woods-Fittig reaction. But what is the Woods-Fittig reaction? You can see for Woods we are using alkyl halide, for Fittig we are using aryl halide, and we got here as a alkyl benzene. But here what we have seen, you can see better here in nucleophilic substitution reaction we have seen reaction with the metals. It is a aryl halide on treated with the metal in presence of alkyl halide. You know, but alkyl halide coming from the Woods reaction and aryl halide coming from the Fittig reaction called as a Woods-Fittig reaction, and we got 2 moles of NaX came off. R will attack over the benzene ring. We got the alkyl benzene. But we can write in this way also. See here, this is a chlorobenzene on treated with the sodium. It is a alkyl chloride, means let us say CH3Cl. Chlorine from here, Na from here goes off. Then we are getting here as a R group will attack over the benzene, means here R is in methyl, and 2 moles of NaCl came off. But benzene ring bearing CH3 group is called as a, it is CH3 means methyl, called as a methyl benzene, and but it is also called as a toluene, right? Called as a what? Woods-Fittig reaction. So reaction of alkyl halide towards the benzene. Next one is again we can treat it with the in presence of ether, but medium should be there. This reaction must occur in presence of what? Ether. But one more reaction we can write, and it will be called as a Fittig's reaction. But in Fittig reaction, mein even this aryl halide is there, it should be 2 moles. See here, this is the aryl halide, then 2 moles of sodium, and 1 moles of again as a aryl halide. Halogens came out. What is that beta? Reaction will take place in presence of medium as a ether. This benzene ring will attack on the another benzene ring. Even 2NaX came off. But this will be called as a biphenyl. It will be called as a biphenyl. We can write this reaction how? By using the chlorobenzene. So 2 moles of chlorobenzene on treated with a 2 moles of a sodium. Here chlorine Na came off, and the reaction takes place in presence of medium called as a ether, but where it gives rise to a biphenyl. This is called as a biphenyl, and remaining 2 moles of NaCl came off. Right, but a biphenyl and 2 moles of NaCl came off. But now what we saw here, that is a nucleophilic substitution reaction we saw. And in these nucleophilic substitution reactions, that is the reaction of aryl halides, reaction of aryl halide towards the NaOH, reaction of this aryl halide towards the metal, that is a good fitting, and reaction of this aryl halide towards the metal, what as a fitting. But now this aryl halide can also shows its electrophilic substitution reaction also. But it shows what electrophilic substitution reaction. How it shows electrophilic substitution reaction? Let me explain you it here. Suppose this is a benzene ring having alternate pi bond bonded with a halogen. Chlorine is having 3 lone pair. And you know what a halogen, it is having a minus I of it as well as the plus M of it. But here minus I is a more dominant over the plus I, especially for the halogen attaches to the benzene ring. But now I will show here as a plus M of it of the chlorobenzene. Plus means electron donating group. It donates its electron toward this carbon. Pi bond shifted to this carbon. And you can see beta, I am getting the resonating structure of it, where it shows it will increases the electron density at this position. But at this position called as a what? Ortho position. And now it will get the partial double bond character. Now pi bond shifted back to here. But as it shifted back to here, what happened here? See, this carbon will get positive. It is already having negative. Positive negative pi bond. Negative here pi bond. And again chlorine and carbon में partial double bond character. But again this pi bond shifted back to here and we are getting pi bond here, positive negative pi bond, but a negative charge, partial double bond character between carbon and halogen. Now this pi bond shifted back to chlorine and now the resonating structures will come in this way, 1, 2. Positive negative will make the pi bond and then Cl, which is having 3 lone pair. But in this resonating structure, what did you understand? It is due to the electron donating group, it increases the electron density at this position. This position called as a ortho. This position also called as a ortho. And at this position beta, this position called as a para. Means we can say beta, my electrophile can attack either at the ortho or at the para. Means if I will take here as a chlorobenzene, and I want to attack the electrophile over it, right, in presence of a Lewis acid, but my electrophile can attack either at the ortho position or my electrophile can attack either at the para position. And you know, among the ortho and para will be considered as a major and ortho will be considered here as a minor product. So based on that, the first reaction which one we are going to discuss, that is called as a beta halogenation. Addition of halogen in presence of what? Lewis acid. Halogenation we will see here. Acha, what is the halogenation beta here? Addition of chlorine over the aryl halide. I'll explain you. See here. Suppose this is a chlorobenzene. I want to add halogen like a chlorine. But in presence of a Lewis acid, what is the Lewis acid? We can use anhydrous AlCl3. These anhydrous AlCl3 and Cl2 will form electrophile as a Cl plus, where it can attack either at the ortho or at the para. So I am getting one of the product here as a ortho dichlorobenzene and one more beta para dichlorobenzene. Is it clear? Ortho dichlorobenzene and para dichlorobenzene. Among these ortho and para beta, I will say para is the major product and ortho is the minor product. But as we prepared here as a ortho dichlorobenzene and para dichlorobenzene, in exams they are asking, in competitive exam they are asking this question also. Write the boiling point and melting point order of ortho dichlorobenzene, meta dichlorobenzene and para dichlorobenzene. Remember beta, para structure is having a symmetrical nature and due to its symmetrical nature, its melting point should be very high than that of what ortho, because meta will always be having a less melting point and meta will always be having a less boiling point. Boiling point also less for the meta, melting point also less for the meta, but para is having higher melting point. Reverse order beta. para is having a less boiling point than that of the ortho. So remember, it is the order of boiling point order and melting point order for dichlorobenzene, ortho, para and meta. But after this electrophilic substitution reaction, the second one we'll see, that is after halogenation. The second one we'll see nitration. But what is a nitration? We should know the nitration mixtures. For example, I'll say this is a chlorobenzene, right, beta? And it is treated with the concentrated nitric acid plus concentrated sulfuric acid. Till now we understood, beta, this is called as a nitration mixture, and it is going to produce a electrophile as a NO2 plus, called as a nitronium ion. Beta, it will attack on which position? Beta, it will attack on the position where it will have high electron density. One is at the ortho and another one is at the para. So beta, we know para is the major, ortho is the minor, right? Third one, sulfonation beta here, right? Sulfonation. Can we say what is the name of the compound beta? 1-chloro 4-nitro and 1-chloro 2-nitro. This is called as a 1-chloro 2-nitro benzene. It is called as beta 1-chloro 4-nitrobenzene. That is nitration. But the third one we can say sulfonation. Third one we can say sulfonation. Right, beta, sulfonation. In this case, we are taking the chlorobenzene. Beta, it is treated with the sulfuric acid. That to be, it is a concentrated sulfuric acid. Beta, on heating, it produces the electrophile. What is the electrophile it will produce? Do you know? Beta, it is forming here as a neutral electrophile. That is a SO3. Beta, neutral electrophile means it is in this way: S double bond O, double bond O, and double bond O. This pi bond shifted back to here, it will get negative, it will get positive. This S positive will attack at the either at the ortho position or at the para position, and hydrogen on this place will attack over it, called as a sulfonic acid. But one is at the ortho and one is at the para. In most of the exam they are asking during sulfonation what is the electrophile will produce. But a student will answer it SO3H, but no, it is wrong. It will produce only neutral electrophile SO3, where it will get the polarity between sulfur and oxygen, and positive part of the sulfur will attack here, and negative part over the oxygen will take out or abstract the hydrogen from the benzene ring. So one is a ortho, one is a para. Para will be considered as a major and ortho will be considered as a minor. Is it clear, beta? This is called as a 4-chlorobenzene sulfonic acid and 2-chlorobenzene sulfonic acid. I'll write the name of this one. 1, 2, 3, 4. 1, 2, 3, 4. 4-chlorobenzene sulfonic acid. Right? 4-chlorobenzene sulfonic acid. Then fourth one we'll see, beta, Friedel-Crafts alkylation and Friedel-Crafts acylation. Friedel-Crafts alkylation, and here only I'll write, beta, Friedel-Crafts acylation. But what is the Friedel-Crafts alkylation? Addition of alkyl halide. So one is a chlorobenzene, this one is a alkyl halide. Acylation में बेटा one is a chlorobenzene and it should have acyl halide. What is the acyl halide? You know, CH3COCl is called as a acetyl chloride, and this is called as a beta methyl chloride. Acha, it will take place in presence of a anhydrous AlCl3 called as Lewis acid. But it is going to form the electrophile CH3 plus, and you know this CH3 plus will either attack at the ortho position or it may attack at the para position, where para is considered as a major and ortho will be considered as a minor. But in this case, it is going to form the electrophile. Do you know what? Acyl group. CH3 C double bond O positive charge over the carbon called as the acyl group. It will attack over the halobenzene. That means it is having Cl here and then C double bond O CH3 is at the ortho and one more beta here C double bond O CH3 is at the para. Para will be considered as a major, ortho will be considered as a minor product, right? But one is called as a 4-chloroacetophenone and it is called as a 2-chloroacetophenone. I'll write the name here. It becomes 4-chloroacetophenone. Is it clear, beta? 4-chloroacetophenone. Beta, what is the name of this one? It will be called as a 1, 2, 3, 4. That means 1-chloro 4-methyl. Another one, beta, 1-chloro 2-methyl. I'll write the name of this one. 1, 2, 3, 4. It will be called as a 1-chloro 4-methyl benzene. So beta, it is a Friedel-Crafts acylation because addition of acyl group CH3CO group called as a acyl group, which will attack at the ortho or it will attack at the para. Para will be considered as a major product. So these all are the 5 reactions called as a electrophilic substitution reaction can be shown by our aryl halides, right? Right, beta. This part completely we have seen this preparation of the aryl halide chemical